Hello guys, let's solve this integral right here. Now, distribution. Well, you can distribute x plus 3 as x into that plus 3 into that and separate the integrals and do it, but you can do that, but you don't really have to. It'll just make things complicated, and it's just better if you don't do it. And at the end, the end result you'll get before doing the integral, it's as if you didn't even have to distribute it anyways, so might as well not distribute it, and I'll explain why. But first, let's see how do you solve these types of integrals. Well, for these types of integrals, always look at the function inside of the root and just look for its derivative. Now, the derivative of this 9x squared plus 12x plus 13, it will be 18x plus 12, right? That's our derivative. And as you can see, we have 18x plus 12, but over here we just have x plus 3. So what we can simply do now is just introduce this 18 inside of this x first. We can just multiply by 18 and divide by 18, and then we can fix the constants. But I'll give you guys a note over here on why we're about to do that. Why do we want a derivative to be this part over here? Well, let's say you have the general case over here. Let's say you have the derivative of a function multiplied by the root of that function dx. Well, you can just use substitution. U equals to fx such that du will be equals to f derivative of x dx. And as you can see, our u is this part and du is this and this part. So you just have root u du and root u du. You can simply do that. You can rewrite this root in terms of power, and it's just going to be u 1 by 2 plus 1, which is 3 by 2 by 3 by 2, which is just 2 by 3. So 2 by 3 u 3 by 2 plus c, of course, and this is 2 by 3. U is our function, so that's just our function to the power 3 by 2. So basically we just want this form so we can just easily integrate it. So let's do that over here. And we want 18x plus 12, so just multiply by 18. This becomes 18x, and 3 times 18, 30 plus 24, which is 54, root 9x squared plus 12x plus 13. Now, all we have to do is we need to have that plus 12 such that, well, we can get this part over here. But we kind of have excess of that. We have 54. So let's just make that 18x plus 12. 18x plus 12 for now. And then let's see what 12 adds up to give us 54, because, well, we originally had 54. We cannot just change that. And here 12 plus, I think it's 42, right? 42 plus 12 is 54. So we can just do this. Root over 9x squared plus 12x plus 13 dx. Now, in this case, we now want to, well, from this step, we now want to distribute it. Well, what we want to distribute is this 18x plus 12 part with this one, and then the 42 with this one, because now we'll get this part over here for the first integral. So this will first of all be 18x plus 12 root over 9x squared plus 12x plus 13 dx, and then plus the integral plus 42, the integral of root 9x squared plus 12x plus 13 dx. So I have to rub this out. Like so. Now, here Well, from this, as I wrote earlier, the simple answer of this will be equals to 2 by 3, the function to the power 3 by 2 plus c, but yeah, right, let's just say plus c. So just focusing on the prime answer of this integral, it's this part over here. So we have the same case over here. If you let u equals to this part over here inside of the root, you'll get that part, meaning you'll just have this, and in the end you'll just have, for this one, you have 2 by 3 into the function, which is 9x squared plus 12x plus 13 to the power 3 by 2 plus 42 integral. Now let's just solve for this integral over here. So let's just write the answer in the next part, and let's just do the integral over here. 9x squared plus 12x plus 13. Now, these types of integrals, these quadratic equation integrals under the root, we want them to be in the form of either these three standard integrals, for which we can just use their standard formulas. So either we want it to be x squared plus minus a dx plus or minus a, or root a squared minus x squared, or minus plus, but that's the same as x squared plus a squared. So let's say these three cases, we either want one of them in one of these integrals over here, and you just have to see the signs. So in here it's quite easy because you just have positive and positive, so this is going to be the x squared plus a squared case. So to have x squared, you just need to complete the square, right? The x just stands for the function part. So we have 9x squared plus 12x plus 13. So we need to complete the square. So this is quite tricky because if this, really not, 3x whole square, let's just write it as a square plus 2ab plus b square, so we can understand what the square will be, and we can just plus minus the constants away. So 3x squared plus 12x. Well, before that, let's just write, actually let's just write it. We want 2ab, right? We already have our a squared plus 2a, which is 3x, into b. Now what will our b be? So to figure that out, just look at the term having x. Well, we have 12x, and right here we have 6x. So we're just missing 2, right? We're just missing 6 into 2, which is 12. That means we have our 2ab. 2 into a into b, so our b is 2, so we're just requiring 2 square, and since we added 2 square, we have to subtract 2 square plus 13. So overall, this part over here, now this is just 3x plus 3x plus 2 whole square, a squared plus 2ab plus b square, a plus b whole square, minus 4 plus 13. Well, 13 minus 4 is just 9 over here. But since I talked earlier how we want x squared plus a square case, a square, so in fact we want this to be a square as well. So rewrite this as 3 square, and there we have it. So let's talk about the formula over here. So for the integral of root x squared plus a squared dx, the answer will be x by 2 root x squared plus a squared by 2 log natural of x plus root x squared plus a squared plus c. Yes, this crazy answer over here. So if you want the proof for this crazy formula, you can check my video. It is the proof by trigonometric substitution. I'll link it up there. It should be up there, infographic card or something. So we have this. So we'll just have to use this formula for this one over here. So what you can do here is you can let u equals to this part, and then du will be equals to, well, 3 dx, right? and then what you'll have is, and dx will be du by 3, and then replace that, you'll have du, and 1 by 3 will go outside, and then this will be u square plus 3 square, which is the same as that. Just instead of x, just write u. But as you can see here, after we write u, we'll just have to go back and replace the value of u, which will be 3x by 2. What that means is we just simply replace this x by 3x plus 2, but uh, we just have to divide it by 3, right? This whole integral, we just have to divide it by 3, and that's all. So this will be here 3x plus 2 by 2, but we have to divide by 3. Or let's say for any cases you get this, you will have to divide by the coefficient of x over here, and well, you just by use substitution you can know y, as I did earlier. You will have to divide by 3, it will be du by 3, like that, du by 5, 7, whatever the coefficient will be. So this is 1 by 3 into this part, which is x square plus a square. Now x square plus a square will be 3x plus 2 whole square plus 3 square, right? Just this. But here, this integral, or this part over here, is just equals to this root, so we can just directly write this 9x square plus 12x plus 13 plus a square, and a square is just our 3 square, because here a is our 3, so this is just 9 by 2, but we have to again multiply by 3 because the 1 by 3 distributes. Log natural of 3x plus 2 plus root, again x square plus a square, this is just that, so this is 9x square plus 12x plus 13. Now we don't have to write plus c, because we're going to have to use this and put it over here. Yes, we're just finding the integral for this, which we put over here. So in fact this is just 42 into, well, I think it would be easier if I did 1 by 3 whole bracket, right? Because here I'll have to multiply by this part, which is 42 by 3, and 42 by 3 is 12, no, 14. So in fact I'll have 42 into 1 by 3, and then just the same 3x plus 2 by 2. In fact there should have been bracket over here, root, this is a long one, 9x squared plus 12x plus 13 plus 9 by 2 log natural 3x plus 2 plus root 9x squared plus 12x plus 13, and then the large bracket, and of course the plus c. And first I'll just keep the 1 by 18 outside and deal with the inside part. So first this will be just 2 by 3, 9x squared plus 12x plus 13 to the power 3 by 2 plus, now 42 by 13 I said earlier is 14, and then 14 I'll just do bracket 3x plus 2 by 2 root 9x squared plus 12x plus 13 plus 9 by 2, this I'll just write here, log natural 3x plus 2 plus root 9x squared plus 12x plus 13, this and that. So brackets a bit confusing, but the modulus sign ends here, then bracket, then that, and I think we can just directly open everything. So I'll have to be a little bit careful, and in fact in this step I can just open it. So this is just 14 by 2, which is just 7. And remember we have 14, so it will be 14 into 9 by 2. 14 into 9 by 2, which is 7 into 9. And 7 into 9 is 63. So we can just remove this bracket. So we'll just have to evaluate this. So this 2 and 18 cancels, giving 9 in the below. So this is 1 by 27. 9x squared plus 12x plus 13. 3 by 2 plus 7 by 18. 3x plus 2 root 9x squared plus 12x plus 13 plus 63 by 18. Well, 63 by 18. So that's 7 into 9 by 18. 9 and 18 cancels. So this is just 7 by 2. Right? 7 by 2 log natural 3x plus 2 plus root 9x squared plus 12x plus 13 plus c, and I think that is our answer over here. Let me just quickly check. So this is correct. This whole thing is the answer of just this integral right here. Yes, and in fact, at the beginning I talked about why the distribution didn't matter. Well, it was because we had to first divide by 18, in which it became 18x plus, let me see the question, x plus 3, so 3 into that is 54. And then we had to adjust the constant, right? We had to do it plus 12 plus 42. Now, if you did the distribution in the beginning, you'll have x root over that integral over there plus 3 into that integral over there. Now, you just have to evaluate this integral, right? So that means you just have to evaluate this integral, meaning this whole thing, right? But here, you would have to introduce the constant plus 12, and you would have to minus 12, or you have to first introduce the 18, divide by 18, and then just add the 12 inside, minus the 12 inside, distribute that, and then again you'd have to do a constant, multiply it by the integral of this. But here you'd have a constant into that integral, or plus 3 into the integral. So instead of being silly and just doing the integral twice, you can just add these two constants. You can just add these integrals. So that means you didn't have to even distribute it in the first place. So that is all, and this is the answer. And if you learned something new, please like and subscribe. Thank you.